All right. Now let's do some examples actually doing this. So here, the directions are to compare a transform graph with its parent function. Again, our parent function, f of x equals our absolute value of x. So the first thing I'm going to do over here on my graph is I'm just going to graph that parent. Come in, graph that parent, absolute value of x, and I'm going to do it in red. It's always good to use multiple colors. There's my parent, and I'm going to label him as such. He's f. Now we want to compare, tell how this is going to change, and we're going to graph him, and we're going to graph this new function. This new function has a name g of x, because our old one's already taken as f. We're going to graph g just based on these transformations. So first we want to look and see, where's my original function? Where's my parent? There's my absolute value, and there's my x. So what's changing? What's happening? Well, we've got a plus. Let's start in. It's always best to do kind of order of operations. What happens first to the x? The subtract 3 happens first. That subtract 3 is happening inside that function. I'm adding or subtracting. That tells me it's going to be a translation. Our translations are all adding and subtracting. Is the adding and subtracting happening on the end or happening inside? Happening inside. So that's horizontal. We know horizontal works backwards. So that subtract 3 is actually going to move this graph to the right. It's going to move it to the right 3. So what I'm going to do is I'm going to come in here in blue, and I'm just going to graph some points that would be on this. I'm not going to sketch the whole thing. Basically, I'm taking this red function, moving it to the right 3. 1, 2, 3. So then basically my graph is going to look kind of like this. There, we moved it to the right 3. Okay, so there's my right 3 there in blue. Okay, so we did the subtract 3. Now there's also this add 2. This add 2 is on the end. Here we're adding 2 on the end, which looks like this guy, f of x plus c. So that's going to move it vertical, up and down. So that plus 2 there on the end is going to take this and move it up 2. So I'm moving now my blue. We did the blue first. So now I'm going to go for my blue, and I'm going to take this blue guy here and move everything up 2. So up 2 gives me right here. Again, get that V shape in. So there's my new graph. Okay, so there's my new graph. One thing we did not talk about yet is this point on my parent. That point 0, 0 is a pretty important point. If I know that point, then I kind of know the shape of my graph. The name of that is called a vertex. It's always important to note where that new vertex is, because that vertex can kind of help us determine what the graph looks like, first of all, and also what its domain and range are going to be. So the vertex in this, the vertex of the parent is always at 0, 0. My new vertex here has moved. It's now to the right 3 and now up 2. So my new vertex is now 3, 2. Okay, so my domain is still all real numbers for this new guy. It's always nice to talk about. My new domain for this guy is still all real numbers. It still goes left and right for forever. Like this graph goes left and right for forever. But now my range is just from 2 on up. My range is now going to be from 2 on up. So g of x greater than or equal to 2 because of that change in vertex. So when it says compare a transformed graph with its parent, our comparing was really this guy right here, right 3 and up 2. I go right 3 for my parent and up 2 for my parent. So there's comparing. Okay. Next, compare a transformed graph with its parent. So again, we want to look at the parent, the value of x. Okay, let's go ahead and let's grab that parent. And again, we're going to do a lot of that. There we go. Okay, let's grab that parent in. It goes like that. And it goes like that. There's my parent, f of x. Now we look at this new graph and we figure out what's going on with this new graph. What's different? My parent is still there. There's my absolute value of x. And we're multiplying outside by a 3. So that tells me it's going to be a stretch or a shrink. Well, 3 is bigger than 1, so it's not a shrink, it's a stretch. And it's going to be a stretch by what we say, a factor of 3, because it's 3 times bigger. Okay. So I need to stretch this guy up 3 times. How that's going to work is this original point is over 1, up 1. I now need to make it 3 times farther. It's up 1. If I go 3 times that, it's now going to be up 3. It's now going to be up at 3. The next point, I don't know, let's do the next point here at 3. The one that's up 3, it now needs to be 3 times farther. So it now needs to be 3 times 3, 9. 3, 6, 9. And once you get a few points, and this first one, 0, 0, is still going to be at 0, 0. I probably should have made these different colors. Because 0 times 3 is still 0. So really, it's just stretching this guy up super skinny like that. And then it's going to do the same thing on the other side. Because my parent graph has what we call y-axis symmetry. What happens on one side happens to the other. It reflects over. I can kind of like flip this over. If I fold it down here in the middle, these two sides land on top of each other. And you can use that to help you graph these. So compare the transform graph. We do. It's 3 times bigger. Notice the stretch or shrink does not affect the vertex at all. The vertex is still there. The vertex is still at the point 0, 0. It doesn't affect that at all. Okay. All right. So now this next one, task 4, we want to construct a function. So here they give us the parent. Here in blue is that parent graph. We want to write an equation for g. So the first thing I need to look at is how do I get from the blue to the red? The first thing I notice is I'm going left 1 unit. So I need to take my parent. So, and they give you kind of a general idea on what your function should look like. Here, all this is showing is that I could have a number multiplied out front, again, which is that stretch or shrink. I could add or subtract inside, which moves it again left to right, and I could add or subtract outside. Okay, the reason they have this as negative is to denote the backwardsness of horizontal. That denotes that backwardsness. Okay, so if we go ahead, sorry about that, Belle. So let's go ahead and let's move this guy. So it moved left 1, so that's taking the absolute value. Left 1 is going to add 1 inside that function. Okay, now instead of going, so that's adding 1, so that's moving it left 1. Okay, so we got the first bit down. Now next bit, we need to look to see, so that moved us left 1, but normally it's over 1, up 1. This one's over 1, up 2. That's twice as far. So that tells me that's a stretch by 2. So here I have that stretch by 2. It's not moving it up or down at all, so it's just right there at 0, 0. So there's my new function. Stretch by 2, left 1.